Okay, now for preliminary stage, which involve go to the site, call that field work over, quick site visit, and we do this. Maybe you can involve trial pit, test pit, or call it trial pit or trenching. We can do geological mapping on exposed rocks or any outcrop or any exposure of the soil. You can do sampling or mapping and then do this sampling on jointed rock or soil. So this is in preliminary. So for example, like this is a preliminary study. If you go that side, you can do this trenching, you can do this logging from top to to 2 meter or about 2 meter. You can see the layer of soil. So and then work around, you can see you can see boulders on the side. So then it's involved in planning. So and then after that, if you see from that exposure boulders, you can see this area is granitic. So you can see this is granitic rock area formations. Yeah, is confirmed from this. You can confirm from the geological map. Then in the main stage, which involve normally in site investigation involve borehole drilling, is conventional technique. For that conventional technique, borehole drilling. Sometimes we do this JKR probe or Macintosh probe, which is to get the soil profile. The main purpose of this borehole drilling is to get the soil profile. So we want to know the profile of our, let's see, we have soil here, the top layer. So we can want to see how our soil profiles look like. Means what is our underground, our subsurface looks like, the model of the subsurface. So based on the geological weathering, based on the geological structure, then this information you can predict. Let's say you're working with these in granitic rocks, so you can deal with the soil weathering profile, which is grade 6, grade 5, grade 4, grade 3, grade 2, grade 1 rocks. So which is the rock is the ground is increasingly increase their strength, decrease their permeability, and decrease their deformability based on previous chapter. So and also another technique that we have to get the soil profile or ground profile is using geophysics study. So we will discuss this later. Okay. So this is borehole drilling. Okay, this is a machine that we use for borehole drilling. So normally we use wash boring machine, which is we install this is the machines. We have to put casing on that to prevent collapse of this soil to this hole, and then we have core bit to drill rocks, the core barrel. And for that you can get the soil sample. Okay, we taken using split barrel. We show you that is a split barrel. And then we have if you have rocks layer, we can get the rock sample of rocks. Based on that, we can identify type of rocks. Okay, this is yeah, we have casing here, and then this casing is act as a drilling shoes, which is the this casing as a to prevent the collapsing of the soil, and then also as a drillings. Then after certain layer, they have, if you have a hard layer, so this drive shoes can penetrate, then we can use this rock bit, core bit, core bit, core bit. And then this is this machine looks like. We have a rod here, we have casing here. This is casing, this rod, this is our machines. Then look on this video. This video shows you how we do the penetration, standard penetration test. See this, pushing up, and then gravity. Then they counted numbers of blow. So that people count the numbers of blow that we recorded on our log. It's very important to get the soil profile based on the SPT value. Okay. This is the, when we do this SPT value, this is a split barrel that we use for to get the sample as well as to get the numbers, SPT numbers below. For example, here this is a job that we did in Jasin. So this borehole number 4 we did on 2019. So this sample number at depth 1.9, 1.5 meter up to 1.95. So here is 45 meter. Distance from this, from here to here, end to end is 450 mm, which is 0.45 meter. And then the numbers of SPT is 14 for this depth. Okay, and then you can see this sample here. Then from that sample they get the sample, put in plastic bag, and then do the soil classification. Okay, similar like this. This is at level 18 meter, 18 meter to 18.45, and then you can see numbers of SPT blow. Still number 4, and then you can see this layer of soil. There you can see the texture of rock. You can see the here you cannot see any texture of rock, but here you can see the texture of rock, which is you can see the light foliation. This rock type is meta-sedimentary rocks, metamorphic type of metamorphic. And then yeah, this is 19 meter. Then to the 5 meter, you can see the numbers of blow already reach 50, and then they have to continue the SPT and blow. Maybe depend on the project, depend on structure they build it on that. Maybe 3 times SPT blow or 5 times SPT and 50 blow 5 times or 3 times. So that's how they terminate the borehole works. Sometimes they terminate after they get after coring the samples up to certain depth. Okay, this is split barrel, yeah, to get soil sample. And then from that boring record we have information like type of soil. When we do the soil classification, we can get the type of soil. We get the soil rock sample, we can get the type of rocks, and then depth for each soil type, this soil or this rock, or numbers of blows, SPT blows, and we can get the water static level, groundwater static level. This is an example of bore logs, which is the information on that. We can see borehole number 4, then they do this water levels, yeah, 0.6. This is at UTHM in 2002, a long time ago. So yes, you can see here the SPTN value is 0 up to 7 meter. You see, very soft rocks, very soft soil in our UTHM grounds. 0 means just using hammer wheel. You see the hammer wheel before. That hammer, they just put the hammer, the rod is dropped without put any wicks, without dropping the hammer. So just imagine how soft that our ground up to 7 meter, and then the soil now increased to 2, also up to 13, and then you can see this is how they classify the soil based on the sample we get from these uh, split samples. They do this soil classification, and then they put here is a depth, the depth, and then the recovery. I mean, recovery here mean the sample they get how many percents from 450, so 70% from 450 mm. So this is how they get the samples, and then this number of the blow they count it. They use they have a 75, 1 2 3 4 5 6 division. They put this every division 75, so they just count the last four only. Last four division they count it as a numbers of blow. So meaning here is got 2 because based on that 4, last 4, not 3. Yeah, so here we got 3. You can see here, let's see last 4 here, they got 3 3 3 9 plus 4 13, so they get 13. So that's how they count the numbers of blow. This is first 2 here division 150 mm, which is for just setting the equipment. So this is if we have cohesive, they stop to, if we have 50 blow, we call that very dense, 30 can hard. For cohesive like sandy, non-cohesive like clay, silt, they classify like that. So we have 0, 4, 10, 30, 0, 2, 4, 8, 15, 30. If we have 0 to 2, we can very soft or very loose. So the cohesive for clay, non-cohesive for sand. 2 to 4 is soft, 4 to 8 is called firm, 8 to 15 stiff, very stiff and hard. Okay, that's how you read these ball logs. Okay, similar like this. So this is how they can get this. This against the how specify the soil based on the numbers of SPT. SPT. This is all based on SPT blows, which is here. Yeah. So based on this last 4 divisions. Yeah. Okay. Then we can get the sample, disturb sample. Then from that sample we can do this grain size analysis, plastic limit analysis, specific gravity, organic content. Then we can do the soil classification. So we can take as well the undisturbed sample to get the consolidation test, hydraulic conductivity test, shear strength test.